Hi, I'm going to present the final experiment simulation. Okay. To start with, I would like to introduce my presentation by revealing the three laws of planetary motions as introduced by Kepler. Such laws determine the way planets move and the reason that they move in some patterns. The first law of Kepler is that the planetary orbits are elliptical and not circular. The second law of Kepler describes the varying speed of a moving planet. According to it, a line that connects a planet with the sun has the same area as a line at the same time. The implies that the closer and the planets are to the sun, the farther they are. The planets that are more distant moving at a slow rate. The second law of Kepler connects the connection between the distance and time. According to it, the couple of the average distance of a planet to the sun is proportional the square of orbit period. This implies that more distance planets require a long time to orbit at once. The orbits of planets near the sun and completed much faster. I will then describe my uh, responses to question 9 and question 11. Beginning with question 9, I modify the question 9 to the planet and the moon simulation. I noted that the planet had minimal movements such as mentioned where a slight a tidal focus by the moon in its movement around the Earth. In the case the planet does not orbit around the sun, as is different in the case of the sun and the planet system. The mass of the central object in question 1, 4, and 7 is approximately 333,000 times the mass of Earth. The mass is near the mass of the Sun, but is question 9. The total mass of this is but one Earth mass. The mass is much less compared to the mass of the Sun. Due to this disparity, the movement on question 9 seems to be less strong and evident. In question 11, I mentioned the size of variables on the simulation with the help of the lunar. Each box in the grid has a approximately of 74 million kilometers. According to my measurements, this distance that is approximately to be have an astronomical unit. I was able to compare the size of the orbit and the optional period of to find that the planet depicted was close to the Earth. The values are very close to the known distance and time period of the Earth. Question 15 tests a variety of four simulations that vary the distance of the planet to the Sun. The finding is a cleaner indication of the validity of the second law by Kepler. Planets that are located far away take a long time to revolve around the sun. According to the law, the values were very similar when I computed the radius with the help of given equation, the deepest agreed calculation between time and distance. The experiments demonstrate that the second law of Kepler is applicable in practice. Based on the experiment, I have gained a number of significant concepts. To begin with, I learned more about the way planets will revolve around the sun. I was informed that their movement is controlled by gravity and distance. Second, I gained a better understanding of the law of Kepler and their application in explaining the movement of the planets. Lastly, I learned to be more aware of the location of the Earth in the solar system. I have realized the reason why some planets travel quickly and some travel slowly. Thank you for listening, and this is my revenue. Thank you.